All right, well, again, thank you all so much. So it is my job to bring these global scale climatological phenomenon down to the scale of Maine's coast. This is a complicated slide outlining all of the different ways that increases in carbon dioxide in the atmosphere impact our oceans. The three we're going to focus on today, our ocean acidification, or the decreasing pH of our ocean. We're going to be focusing on sea level rise, and we're going to be focusing on ocean warming as well. So this slide shows two trends. One on the left is a very famous slide from the Mauna Loa Atmospheric Observatory in Hawaii. The red line shows a significant increase in carbon dioxide in our atmosphere over the last 70 plus years. The green shows the amount of dissolved carbon dioxide in the ocean in a nearshore observatory, also off Hawaii. And the blue shows the decrease in ocean pH, or the acidification that we've experienced in the ocean because of dissolved carbon dioxide. The figure on the right highlights where we may end up depending on how we continue to emit carbon dioxide into the atmosphere. So the chemistry behind ocean acidification is far more complex than I am able to express tonight. We have an amazing ocean scientist on our staff who specializes in this area. But in general, ocean acidification lowers the pH and reduces the amount of carbonate ions that are available for shell-making organisms in the ocean. And Maine is uniquely vulnerable to ocean acidification because of our cold water, both within the Gulf of Maine and that also because of the cold fresh water that's coming into the Gulf of Maine from the Labrador Current to the north. And the semi-enclosed structure of the Gulf of Maine makes it act almost like its own little sea. So the residence time of water here is usually longer than in other places in the ocean, increasing the impact of ocean acidification. But why does this matter to us? Well, if you look at this slide, you see pictured in the largest slice of our coastal economic pie, the iconic lobster. 75% of the species that people grow or harvest in the Gulf of Maine that are the backbone of our $3.5 billion seafood economy rely on carbonate ions in some way, shape, or form to make their shells. If ocean acidification continues, these species will be impacted. But there are positives. What you see here is a figure demonstrating the co-location of sugar kelp in aquaculturally grown species and blue mussels. This study that we embarked in partnership with Bigelow Laboratory for Ocean Science and Bangs Island Mussels in Casco Bay demonstrated that sugar kelp can locally ameliorate or reduce the impacts of ocean acidification around shellfish farms. The mussels that were grown in this amelioration halo, as it's called, had thicker shells and bigger meats. So utilizing economic opportunities like kelp aquaculture on the coast can help locally address some of these challenges. If we think more broadly about the potential for seaweed aquaculture, there's some conversations in the state about utilizing it as a carbon sink, sinking large masses of seaweed offshore. Won't get into the complexities there, but it's generally not a good idea. But if we decide to use seaweed, which can be utilized for a variety of different purposes, to replace higher carbon items like foods or feed inputs, we can create a somewhat circular seaweed economy, whereby seaweed is taking nitrogen and carbon dioxide from the oceans, sequestering it, and then also helping to reduce things like methane from cattle feed. Now, next on our list is sea level rise. So I pulled these figures today from the Maine Geological Survey's sea level rise dashboard from the nearest tide gauge to this area, which is over in Bar Harbor. And you can see these orange dots. On the top of the left-hand figure, you can see the historic highs, the highest sea levels recorded by month. And you can see 3 of them so far this year have occurred in 2023 in the history of the over 100-year history of these tide gauges. And you can see 2023 on the right-hand side is already well above the normal range of sea level rise increase that we've experienced in the past decade or past 2 decades, which is already increasing at a faster rate than it has for the previous several hundred years. Maine is preparing for this, though. They've recommended and recently put in place requirements that coastal infrastructure must manage to 1.5 feet of sea level rise by 2050 and should probably think about preparing for 3 feet while also encouraging 4 feet by 2100 and preparing for the extreme case for critical infrastructure like wastewater treatment plants and critical roads for 8.8 feet of sea level rise by 2100. It's a lot. But what does this actually mean? Why does sea level rise matter? Here's a somewhat familiar site, the Deer Isle Causeway in a winter storm. Talked to Kathleen Billings, the town manager, sometimes about the sheer cost of having to snowplow seaweed off of the causeway, let alone the infrastructure damage that happens during storms like these. It can cause saltwater intrusion or saltwater overtopping of freshwater aquifers. This is the island of Monhegan. They have a very vulnerable and low-lying aquifer that the entire island relies on that is precariously positioned to be overtopped by sea level rise. Working waterfront infrastructure like Brown's Boatyard on North Haven, the entire downtown of Vinyl Haven, and the downtown of my hometown of Damariscotta are already feeling the impacts of sea level rise. But people are already taking steps. Stonington has invested in an assessment of their vulnerable roads, which helps them prioritize how to direct resources to those areas most likely to be impacted. Damariscotta started a process, much like you have here in Brooklyn, that allowed them to be well positioned with the preparation and the plans to receive millions of dollars to support some of their infrastructure improvements. And thanks to the newly found Community Resilience Partnership to the Governor's Office of Policy Innovation in the Future, communities like Brooklyn are able to put in place the foundations that will allow them to capitalize on the millions of dollars of federal funding that are flowing through the government right now, and the many state level programs that are able to support infrastructure resilience for your community. And here's just an example to highlight that Brooklyn is not in this alone. This is simply the list of communities that have actively engaged in the Community Resilient Partnership. But there are towns and there are communities that have gone before you from which you can draw inspiration and advice and experience. And just for some examples, one of the things that the island of Islesboro has done is utilize the $50,000 planning grant or the community action grant that comes with the Community Resilience Partnership. The same grant Brooklyn will be eligible for down the road to do core samples of their marsh to understand the role of sea level rise and how it has impacted the island in the past, to install their own tide tracker to understand the very unique impacts of sea level rise on their community, and to support community-wide art engagement, starting at the lowest levels of the schools to bring to light the impacts of sea level rise and what they're going to bring to the community, to start to have a conversation around what can be done. And now, last but not least, and probably the most prominent issue that's facing the Gulf of Maine right now, and one that is on the front page of many newspapers over the last several months, is ocean warming. So here we see pictured the Gulf Stream, and in the blue on the upper right, the Labrador Current. So in 2010, what was termed the Gulf of Maine regime shift happened. And what this led to was an influx of warm water because the Gulf Stream basically shifted north for a variety of climatological reasons, many of which are connected to some of the global drivers Paul has highlighted. But what this means is that warm water is coming into the Gulf of Maine to a greater degree and for a longer time than it has in a very long time. And this is a regime shift. So this is the new normal. If trends like this continue, by the time we hit 2500, down East Maine's water temperatures, the average water temperature for areas around Brooklyn will be 3.8 degrees hotter than the monthly average prior for the last 100 years. So this is the equivalent of the waters in down East Maine being as warm as the waters in Long Island Sound and coastal New Jersey are now. Why does this matter? Well, one of the many things that this impacts is the distribution of species. Here we see the distribution and abundance of lobster in 1972 and in 2019. You can see it's a heat map, so the darker red colors are the greater abundance of lobsters. So you can see the warming of the Gulf of Maine has brought great abundance of lobsters to down east communities and to the Gulf of Maine writ large. But lobsters, like any creature, have specific thermal envelopes that they like. They don't like things too cold. They don't like things too hot. So what we're starting to see as an impact of this warming is not just a decrease in the lobsters that scientists at the Department of Marine Resources are catching in what they term their ventless traps, where traps that catch every single lobster, but also all of the different metrics that are evaluating the population of lobsters. They're showing declines, mostly in part driven by ocean warming. Ocean warming also disrupts predator and prey dynamics. I'm sure everyone in this room has heard about right whales. If we look at the driving factor of what is changing the distribution of right whales, it is not simply a question of right whales engaging with fishing activity. It is in fact right whales relocating to find their food because the Gulf of Maine has become too warm to support the populations of a copepod, Calanus finmarchicus, which have provided the foundation of the food chain for many species in the Gulf of Maine. This has caused them to search for food elsewhere where they have engaged and interacted with fishing gear in ways that they haven't in the past because there have never been whales there before. These types of predator and prey dynamics will continue, not just with right whales, but with species like herring, cod, black sea bass, which is a southern species. Longfin squid, which is another southern species, will increase in abundance. And as these impacts change the foundation of our fishing economy on the coast of Maine, fishermen are already taking action. So one of the things we were privileged to participate in was a training program for lobster fishermen to start aquaculture farms. Here you see Josh Conover from the island of Islesboro, who is still an active fisherman and has one of the largest mussel farms now in the state of Maine. So by diversifying our marine economy and the individual businesses within our marine economy, we're able to increase the resilience of these businesses and therefore the coastal communities themselves. And it all starts with mitigation. So Cranberry Isles Co-op was the first co-op to establish solar panels on its roof, fully powers all of the operations at this wharf. I believe their anticipated payoff for this investment was 7 years, but I think they're looking at next year. This is going to be, they have received a full return on their investment and will receive free electricity for the life of the co-op. And I would be remiss if I didn't mention a conversation that Doug and I love to have is around electric boats. So there are numerous opportunities to bring low carbon solutions to support our marine economy. So we partnered with various groups, including Gulf of Maine Research Institute and our Climate Common, to deeply understand what are the opportunities for decarbonization in the working waterfront. 2 weeks ago, we launched the first all-electric working boat for a boatyard on Islesboro. The technology is here to transfer all of our combustion engines for our aquaculture fleet and for harbor masters to electric. So by starting, there's no reason why our marine economy can't help the state lead the way in the state's climate action plan. And it starts in places like this. So thank you all for your time. And I'm happy to follow up with anything that was a whirlwind tour of three very complex climate drivers and their impacts on the coast. So with that, thank you.